Hey friends, it's MoNaCo here with our 7th homework note video on atomic theory. We're going to focus today on something called a Bohr diagram. And you might think, oh geez, this is going to be boring. But this is a different way to pictorially, graphically show an atom, its nucleus, its nuclear charge, its electrons, and where they are oriented around that atom's nucleus in the principal energy levels. So you're going to know how to draw Bohr models of atoms to show protons, neutrons, electrons, and the principal energy levels and how it's all arranged together at the end of this video. Okay, so what's our lead-in? In what case can we draw a model of the atom in 2 dimensions? Well, models in chemistry, as you know, represent something that you cannot see. And they're always approximations that can be useful anyhow. So models are numerous of the atom, but the Bohr model is good for showing those locations of protons, neutrons, and electrons, as well as the principal energy levels. This model is admittedly out of date. The wave mechanical model of the atom is true. Well, it's more true than the Bohr model. It's just that this one is very useful because it's an organizational structure. It can help you think about how an atom's protons, neutrons, and electrons are arranged in a way that makes sense to you. It's kind of also known as a planetary model. It's easy to work with, that's why we still use it. So let's talk about Bohr diagrams. It's one method for expressing electron location in an atom or ion. All the electrons must be drawn. It's called a Bohr ring. So you put all the electrons on the ring around the Bohr diagram, Bohr ring. Get it? Haha. So what you got to do is you got to look up an electron configuration for the element on the periodic table. And you got to work from there. So for example, we're going to do oxygen. And the electron configuration for oxygen is 2-6. So it has 2 principal energy levels, 2 kernel electrons, and 6 valence electrons. So we draw a nucleus with a square in it and notate the correct amount of protons and neutrons inside. So we're going to draw our nucleus as a square. You could also draw it as a circle. Personally, that's what I do. Either way, you got to draw a nucleus that represents where the protons and neutrons are and their number. For oxygen, there is 8 protons and 8 neutrons. The next thing you got to do is you have to put in the correct number of principal energy levels from that electron configuration. Since the electron configuration was 2-6, that means there's 1 principal energy level, 2 principal energy levels. So we took 2 rings around our nucleus. We haven't drawn the electrons in it all yet, but we have the principal energy levels present now. The next thing you got to do is you have to start filling in where the electrons are. And the way you do this is you place the correct number of electrons in the area that would be correspond to the number 12 of the phase clock on the orbit. And we usually go 12, 3, 6, 9, as you usually fill around. The first 2 should go together like that. So the first principal energy level, according to oxygen, had 2 electrons in it. So we put the 2 electrons on the first ring. Then you go to the second energy level and you put the other electrons in. You start by doing it at the clock position, 12, 3, 6, 9. There is some discussion as to how this is done, quote, properly, but that involves an AP level conversation about quantum theory and hybridization of orbitals, which we're not going to go into. So the 3, 6, 9, 12 clock face method of filling in the electrons will work for your chemistry class. So what you got to do is we filled in 4, and then we start pairing them up. So the second principal energy level had a total of 6 electrons in it. And so we filled the 4 in at the 3, 6, 9, 12, and then we started again at the 3, 6, 9, 12 to finish up the last 2 electrons. And there you have it. You have yourself a Bohr diagram of the atom of oxygen. If you draw the isotopic notation for oxygen, this would be oxygen 16, right? There's one way to do it, or oxygen 16, or oxygen 16. Those are 3 different ways to represent that in isotopic notation. Notice there's nothing in the top right corner because it is not an ion. So let's do a little bit of practice here. You need a periodic table in order to do this. I've got plenty. There's one posted on my website as well as the ones that we'll be giving you in class. So for carbon, I find that it has 6 protons, 6 neutrons, and 2 principal energy levels. So I'll say protons equals 6, neutrons equals 6, and put that in a circle. I like to do circles instead of squares. Equally correct. Then I put 2 principal energy levels around it because I have 2 numbers in my electron configuration. I'm going to switch colors to do the electrons here. I'm going to put in my electrons, 1, 2 for the first principal energy level, and then I have to put 4 in after that. 2, 3, 4. The reason why we go 3, 6, 9, 12 is has something to do with valence shell electron pair repulsion theory, or VSEPR. Basically, electrons are negative and they don't like to be next to each other unless they have to be. So that's why we spread them out as much as we can. Let's do a ion. Let's do a positive 2 ion for calcium. Ooh, calcium. 20 protons, 20 neutrons. So P equals 20, N equals 20. This one has 4 principal energy levels, but notice that it is an ion. So it is missing 2 electrons from the standard periodic table. So I have 2882 is my normal electron configuration for calcium, but this is calcium plus 2, so the configuration is 288. So I really only have to draw 1, 2, 3 principal energy levels and fill them in with the electrons. 2, 1, 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the last principal energy level that is currently occupied in this ion also has 8. So 1, 2, 3, 4, 5, 6, 7, 8. There it is. Okay. Now let's do a negative ion, and that'll be it for the practice. You should do the other 5 that I'm not doing on your own. Let's do S2 negative. Sulfur 2 negative. Well, sulfur's got 16 protons, 16 neutrons. And it typically has 3 principal energy levels, but this has a 2 negative charge, which means it has 2 more electrons than normal. So instead of 286 from the periodic table, it would really be 288. There's my nucleus, so I have to have 1, 2, 3 principal energy levels for the 288. And then I got to fill in my electrons. 2 on the inside ring, 8 on the second principal energy level, 8, and then 8 on the third principal energy level. There it is. So those are Bohr models. They're there to show you that the atom has protons, neutrons, and electrons, and how their electrons are arranged around the nucleus. That is the point of a Bohr model. So follow that simple procedure every single time. The only asterisk or buyer beware is that you might be asked to draw a Bohr model of an atom or an ion. Atoms are easy. You copy what you see on the periodic table. Ions, you got to take that extra step and think, okay, does it have more electrons or less electrons than what I see on the PT? Thanks, everybody, for your time. Have a good one.